6.7 today. 6.7, we are talking about inverse functions. An inverse function simply means that x becomes y and y becomes x. So I'm going to start with something really easy. So let's say I have a table that is x and y. And in my table, maybe I have some points. Let's go with the points. I don't know. How about 1, 1, 2, 3, 3, 7, and 4, 9. Okay? If I were to plot these, and this is my original function, if I plot these, I would plot the point 1, 1, 2, 3, 3, 7, and 4, 9, right? You see I kind of got a little curve going up. For an inverse function, I would have x and my y inverse. When we say inverse, we're going to use the little notation of a little tiny negative 1 at the top. And it just means we flip these. So it'd be 1, 1, 3, 2, 7, 3, and 9, 4. Now if we go ahead and plot the inverse, there we go. We have a point at 1, 1. We have a point at 3, 2. We have a point at 7, 3. And we have a point at 9 and 4. So it's the curve going, this direction compared to the one that was going this direction. Well, not like that. Okay? So that's the basics behind doing an inverse. Now, here's the one thing I need you to take away from this. When you are graphing, an inverse will reflect over the diagonal line y equals x. That diagonal line is the line y equals x. An inverse will reflect over that. Because tell me, what are we doing with our x and y? We're flipping them. Exactly. So that's why it ends up reflecting over top of the other one. So here is example number 1 today. Example 1. This will cover your 8 through 10. It says find the inverse and graph both the relation and inverse. So very close to what I just did up there, right? So I'm going to give you a table. In that table, my x and y. Maybe I have x is 1, y is negative 2. When x is 2, y is negative 5. And when x is 3, y is negative 2 again. Negative 2 again, sounds good. All right. So then I want to do my inverse for that. So I'm going to do my table. I have x and I have y inverse. So we're going to flip these. It's going to be negative 2, 1. Good. Negative 5, 2. Good. Negative 2, 3. Now let's go ahead and plot them both on the same graph. So plotting 1, negative 2, over 1, down 2. There's a dot. How about 2, negative 5? And 3, negative 2. So now my inverse is at negative 2 up 1. At negative 5 up 2. And at negative 2, up 3. So in the first one, if I were to connect my dots, it kind of makes this V shape, right? In my inverse, if I were to connect my dots, it also makes a V shape, but on its side. You'll see it reflects over this beautiful diagonal line. Does everybody see that reflection? Okay. All right, so any questions so far? All right. Now, we're going to find our inverse algebraically. Has some beautiful steps to it. Ready? To find inverse algebraically. Step 1, switch X and Y around. Step 2, solve for Y. And then step 3, write with inverse notation. So for example, if you have a function, let's say y equals 3x plus 2, and we want to find the inverse. The very first thing you do is switch your x and y around. So step number 1, you would have x equals 3y plus 2. Step number 2 says to solve for y. So now I want to get y by itself. So we're going to subtract 2. I agree. X minus 2 equals 3y. Then what do I have to do? Divide by 3. All right, when I do that, my y is now by itself. So then step 3, we're going to write it with inverse notation. So we take our y, we write it with this little negative 1 at the top, and it equals x minus 2 over 3. All right, not bad at all. Okay. So now here's what I want to ask you next. Do you guys remember how to tell from a graph if something's a function or not? What test did we use when we graph something to decide if it's a function? It is. Very good, Jared. It's the line test, right? The vertical line test? Okay. So one of the questions you're going to be asked today is if your original relation is a function and whether your inverse is a function. Okay. So on this one, if you were to graph that, I'm going to pretend we graphed it in my graphing calculator. And we came up with a line that kind of looked like that. If we graph that one in our graphing calculator, you'd come up with a, let me put it in a different color, a line that would kind of look like, oops, not like that, hold on. All right. So, looking at the black line, is the black line a function? So this one is a function. I agree. How about the red line? That's my inverse. Is that a function? Yes, very good. All right, so here is example number 2. Are we ready? Example number 2 covers your problems 12 through 20. 12 through 20 says, find the inverse. And then it says, is the inverse a function? All right, let's go with y equals 3x plus 7. All right, so first we got to find our inverse. The very first step is to switch x and y around. Good. X equals 3y plus 7. Now we solve for y, or we get y by itself. So we're going to subtract 7. So x minus 7 equals 3y. Divide both sides by 3. And our inverse function, excuse me, y inverse equals x minus 7 divided by 3. Now you'll notice that my x is to the first power. What kind of function is that? Or what kind of relation is that? What kind of x to the first power is called? Linear. You guys, we just learned this. This was part of this chapter at the very beginning. You're going to be tested over it, remember? Linear, quadratic, cubic. Yeah, all those words? Okay. So in this one, since x is to the first power, this is linear. If I have something that's linear or makes a line, is it going to be a function? Yes, it is. So this is a function. Okay. I'm going to go to example 3, Devin.
Wait, we were going to start?
No.
What would not be a function?
I'm so glad you asked. That's perfect. All right, example number 3. Let's do, this is going to be 22 through 28. In this one, I'm going to ask you to graph the relation and its inverse. All right, and maybe we have something like y equals x squared plus 1. So somebody enlighten me, if I'm going to graph that, what is that? It's quadratic, so it makes a parabola. How has that parabola moved? What has it done? What does this plus 1 at the end tell you you're doing with your u? Up 1, yep. So here's my parabola. It's moved up 1, it's right here. This is my original. If I were to reflect this over this line, right, this parabola reflects, if I fold on that line, my inverse is going to be the same parabola, but on its side, right? Excuse me. So now, our original one is a function. It passes the vertical line test. But what about our inverse? Exactly. If we were to draw a line through our inverse function, it crosses the two sides twice, right? Right, so this is not a function. This one is. This one is not. Okay? Huh? Well, you're fine. You'll be okay. You're hanging tough. Example number 4. Example number 4. It says, find the inverse. Then state the domain and range for the relation and its inverse. All right, this will cover 30 through 34. So if I were to give you, well, let's go this way, f of x equals the square root. Let's go x minus 3. Here's my original function. First of all, f of x really means what? Y. Very good. Okay. Before we do our inverse, let's talk about our domain and range. All right? Our domain for this one, is there an x in the denominator? Is there an x in the square root? Okay. So that means I would take what's underneath the square root, x minus 3. It has to be greater than or equal to 0. Solving that, I add 3 over, I get x is greater than or equal to 3. Or the domain, put domain here, sorry. Domain is 3 to infinity. All right, now, good. Now we're going to find our inverse. And we'll get back to the range in a minute because I want to show you something super cool. All right, so we're going to find our inverse. We're going to switch x and y around. So x equals the square root of y minus 3. How do we get rid of that square root? Square it, right? So you raise it to the 2? Okay. So we're going to square this side and we're going to square this side. So I get x squared equals, on this side the square root and the squared cancel, I get y minus 3. Then what do? Add 3 to the other side, so I get x squared plus 3 equals y, and I'm going to write that as an inverse function. So I can either write it as y with a little negative 1, or since it started off as f of x, I'm going to put f of a little negative 1 of x. Again, still means the same thing. Equals x squared plus 3. All right, now, domain for this one. Is there an x in the denominator? Is there an x in the square root? Good. Negative infinity to infinity. The range for this one. Talk about the range here. I don't want to go that far. The range. If I were to graph this, let's talk about it that way. The range would start at 3, and it's a parabola that does this, right? So our range always started from the bottom and went up. So our range would start at 3 and go to infinity. So we're going to talk about, what do you notice about the range of our inverse and the domain of our original? They're the same. And remember, domain is x, range is y. They switched. So what do you think is going to happen with the range up here? Well, no, it's going to be this domain. So what happens is the domain and range, they flip-flop. Okay? So this would be negative infinity to infinity. Crazy, huh? One last example and I'm done. All right, example number 5. Thank you. Example 5 covers the rest, which is technically 36 through 40. The directions are going to ask you to, if I have f of x equals 10x minus 10, find f inverse of f of 3. Thank you. So first thing I want to talk about is I want to talk about the inverse function. In order to know, we need to know what the inverse function is, right? So we're going to start by finding the inverse, which means we switch our x and y around. So over here, I'm going to take this, and I've got x equals 10y minus 10. Then what do?
Y equals 10x.
Good. Not quite. Close. Okay, we switched our x and y around, so we're going to add our 10 over, right? So I have x plus 10 equals 10y. Then I divide by 10. Oops. Nope, I went the other way. I switched it on you before you had a chance. All right, so this inverse function. Everybody good on where the inverse function came from, right? Yes or no? Okay. The inverse, or F inverse of x, is x plus 10 divided by 10. All right, so here we go. We're going to take 3, plug it into our F equation. So I plug it in here. 10 times 3 minus 10. 20. Then I take that 20 and I'm going to plug it into my inverse. So I put it in here. I have 20 plus 10 divided by 10. 3. Every time you cross an inverse with its function, whatever you start with, you end with. So do we have to do all that math? No. So how about this one? If we have h inverse of h of 7. What's my answer? 7. If I have g crossed with g inverse of negative 5. It'd be negative 5. Absolutely. Any question? Okay. And then I'm done. We have 8 through 40 even.